We are going to start now lecture 7 of chapter 9 class 11th mathematics sequence and series. In this chapter we will talk about some more properties related to geometric progressions, and further we will study some terms related to sum of n terms of the GP. So the first topic we have over here, it is nth term from the end of a GP. So suppose we are saying that there is a GP whose first term is A and the last term is L, and the common ratio of this GP it is R. Then we are claiming that the last term of this, the nth term from the end of this GP, it is given by the formula L over R raised to the power n minus 1. So what we have is, the last term we have it is L. This is the last term. Now the second term from end, that will be equal to L over R. Third term from end, that will be equal to L over R square. So what we can see, when we are talking about second term, the power we have it is 1. When we are talking about third term, the power we have it is 2. So when we are talking about the nth term from end, the answer we have it is L over R raised to the power n minus 1. So we have this question based upon this formula. It is find the 8th term from the end of the GP this. So value of A we have it is 3. The value of L we have it is 1, 2, 2, 8, 8. And the value of R we have it is 6 by 3 is equal to 2. So using this result, we are saying the 8th term from the end. We are saying 8th term from end, that is equal to 1, 2, 2, 8, 8 divided by 2 raised to the power 7. We are talking about 8 terms, so power is 7 over here. So when you solve this, when you divide these values, the final answer you will obtain, that is equal to 96. Next is problems on finding the GP. So if we have to find the GP whose 3 terms are to be considered, then we consider the terms in the form A over R, A and AR. Similar kind of results we have seen for the AP, where we were saying we are considering the terms in the form this. When we are talking about AP, we were considering the terms in this form. Now for GP we are considering them in this form, so that if we multiply these terms, this R gets cancelled and we are left with this A cube. So these kind of terms we generally consider when the product of the terms is given to us. If there are 4 terms we are talking about, so it is A over R, AR, AR cube and A by R cube. If we are talking about 5 terms we have to consider, then we are writing it is A, AR, AR square, then it is A by R, then it is A by R square. So these are how we can consider 5 numbers in GP. So we generally use these kind of results when the product of the terms or product of these numbers they are given to us. Next is the sum of the first 3 terms of the GP is 13 by 12 and their product is minus 1. So we are talking about first 3 terms of the GP and the product is given. So we are considering it is A by R and AR. These are the 3 terms. So if we take the product of these 3 terms, the answer we have it is A cube and it is given to be equal to minus 1. So we are getting A is equal to minus 1. We are talking about the real sequences. So we are getting the answer is A is equal to minus 1. Now it is being given that the sum is 13 by 12. So what we obtain from this is that minus 1 by R plus minus 1 plus minus 1 into R, that is equal to 13 by 12. Now if we solve this equation, we will obtain the quadratic equation in the form 25R and then it is 12R square and plus 12 is equal to 0, and this gives us the value of R is minus 4 by 3 or minus 3 by 4. So if we substitute these values in this formula, we have a is equal to -1, value of r is -4/3. We have a is equal to -1, value of r is -3/4. On putting these values, we will obtain the two sequences. These are the two sequences we are getting. One is 3/4 -1 and 4/3, and second we are getting it is 4/3 -1 and 3/4. So these are the two sequences, or these are the two numbers, the set of numbers that satisfy these conditions. Now next we have is find three numbers in GP whose sum is 13 and the sum of whose square is 91. So we consider the three numbers. They are a by r and ar. The sum is given to be 13. So a into 1 by r plus 1 plus r, this is given to be 13, and sum of whose square is 91. So it is a square into 1 by r square plus 1 plus r square, that is equal to 91. Now if we square this first equation, we are talking about this equation, if we square this equation, we will obtain a square into 1 by r plus 1 plus r whole square, that is equal to 169. And if we open this square, we will obtain it is 1 by r square plus 1 plus r square plus these two terms, product of these two terms, it is 2, then it is 2 by r, and then it is 2 times r, that is equal to 169. So this implies us that a square into 1 by r square plus 1 plus r square plus 2a square into 1 plus 1 by r plus r is equal to 169. This L is equal to 169. Now if we substitute the value of this term 91 in this equation, we obtain 2a square into 1 plus 1 by r plus r, that is equal to 169 minus 91, and the answer we get, this is equal to 78. And the value of this term, we are saying the value of this term, that is 1 plus r plus this, it is 2a into 13 by 2a square into 13 by a, that is equal to 78. So a gets cancelled over here, a cannot be 0, it is a GP. So what we obtain is that 26a is equal to 78, and this implies us a is equal to 3. Now if we substitute this value of a in this first equation, this equation will become, we are talking about this equation, so it will become 1 by r plus 1 or 3 by r plus 3 plus 3r, that is equal to 13. So this will make the quadratic equation 3r square minus 10r plus 3 is equal to 0, and on solving this we will obtain r is equal to 3 or r is equal to 1 by 3. So we are getting the two values of r, they are r is equal to 3 or r is equal to 1 by 3. Another, we are getting a is equal to 3. Now by substituting these values in the values that we have considered, ar, a and ar, we obtain these two answers, that the required numbers are either 139 or they can be 931. Now next we have is find the three numbers in GP whose sum is 52 and the sum of whose product in pairs is 6 to 4. So either we can, now the sum is given, either we can assume the numbers as a by r, then a and then ar. If we assume these three numbers, it is being given that their sum is a into 1 by r plus 1 plus r, it is given to be 52, and sum of whose product in pairs, it means a by r into a plus a by r into ar plus a into ar, this value is given to be 624. So from all these terms, this r gets cancelled. We are left with this a square into 1 by r plus 1 plus r is equal to 624. Now if we substitute this value in this equation, we will obtain a into 52, that is equal to 624. So this implies us that a is equal to 12. Now if we substitute this value in this equation, we will obtain 1 by r plus 1 plus r is equal to or we are saying into 12, that is equal to 52. So this implies us that 12 plus 12r plus 12r square, that is equal to 52r. This implies us 12r square minus 40r plus 12 is equal to 0. So this implies us that 6r square minus 20r plus 6 is equal to 0. Now the roots of this equation they are given by r is, it is minus b plus minus square root of b square minus 4ac. 4ac will become 144 and divided by 12. So the answer we obtain, it is 20 plus minus, when you solve this value you will get it is square root of 256. Square root of 256 means 16 by 12. So we have two values of r is either 3 or it is 1 by 3. So we have the value of a, we have the value of r. If we substitute both these values in this formula, we will obtain that the numbers we have, it is 4, 12 and 36 or 36, 12 and 4. So these are the required numbers. Now next we have is, if the product of three terms in GP is 216. So again we are considering the numbers as a by r and ar, and their product is given to be 216. So it means a cube is equal to 216. So this implies us a is equal to 6. Now the sum of their products in pairs is 156. So it is a square by r plus a square plus a square r. This value is given to be 156. So what we obtain is that a square into 1 by r plus 1 is 156. The value of a square that we have, it is 6 square, that is 36. So we are getting that 36 into r square plus r plus 1 divided by r is equal to 156. So this implies us that 36r square plus 36r plus 36 is equal to 156r. So this implies us if we take 3 common from these terms, or we are dividing it with 12 we are saying. So what we obtain is that 3r square plus 3r plus 3, that is equal to 13. So this implies us 3r square r minus 10r plus 3 is equal to 0. So this gives us the value of r as 1 by 3 or 3. So what we have obtained? We have obtained the value of a is, 6. The value of r is 1 by 3 or 3. So if we substitute these values in this equation, we will obtain the final answer as, the final numbers are 18, 6, 2, or they are 2, 6 and 18. So these are the numbers that we have. Next is find 4 numbers in GP such that the third term is greater than the first by 9 and the second term is greater than fourth by 18. So suppose the numbers we are saying that are in GP, they are AR square and AR cube. It is given that third term is greater than the first by 9. So we have AR square minus A is equal to 9, and the second term is greater than the fourth by 18. It means AR minus AR cube is equal to 18. So this implies us a into r square minus 1 is equal to 9, and this implies us ar into 1 minus r square is equal to 18. Now if we divide both these equations, we will obtain a by ar is equal to minus 1 by 2. A gets cancelled. We get the value of r is equal to minus 2. Now if we substitute the value of r in one of these equations, we will obtain a into 4 minus 1 is equal to 9. So this implies us a is equal to 3. So we are saying the required numbers are a is 3, then it is 3 in a into r, it is minus 6, then a into r square, it is 12, then a into r cube, it is minus 24. So these are the required numbers in this case. Next is the sum of three numbers in GP is 56, and if we subtract 1, 7 and 21 from these numbers in that order, we get an AP. We have to find the numbers. So we consider the numbers are A, AR and AR square. The sum is given to be A into 1 plus R square. This value is given to be 56. Now next is, if 1, 7 and 21 are subtracted, it is A minus 1, AR minus 7 and AR square minus 21. Then we get an AP. So this forms an AP. So if this is an AP, it means we are having AR minus 7 minus A minus 1, that is equal to AR square minus 21 into AR minus 7. Now on solving this, we will obtain, if you look at these values, it is AR minus 7 minus A plus 1, that is equal to AR square minus 21 minus AR plus 7. So we get AR square minus 2AR, and then we have is minus 8 plus A is equal to 0. So we have AR square plus A is equal to 2AR plus 8. Now look at this term over here. It is A plus AR square is equal to 56. So what we get from this is that AR square plus A is equal to 56 minus AR. So if we substitute this value over here, we will get 56 minus AR is equal to 2AR plus 8. So what we get is that 48 is equal to A into R, and this implies us that the value of R is, this is 3 into AR. So the value of R we obtain, that is equal to 16 upon A. So this is the value of R that we have. Now if we substitute this value of R in equation this, I talk about this equation, we obtain A into 16 by A plus 16 by A square plus 1, that is equal to 56. Now if you solve this equation, you will obtain the quadratic equation in the form A square minus 40A plus 256 is equal to 0, and when you solve this quadratic equation, you will obtain the value of A as 8 and 32, and corresponding to both these values, we will obtain the values of R as, corresponding to 8 we will have it is 2, and corresponding to 32 we will have it is 1 by 2. So these are the values that we will have. We have A is equal to 8, R is equal to 2. We have A is equal to 8, R is equal to 2. When A is equal to 32, R is equal to 1 by 2. So when we substitute these values in this, what we have assumed over here, that the GP, it is A, AR and AR square. These are the three terms. So when we substitute these values over here, we will obtain the final answer as, the three numbers are either 8, 16 and 32, or they are 32, 16 and 8. Now the next we have is the sum of the n terms of a GP. So suppose we are saying that we have a GP whose terms are A, AR, AR square, so on up to AR raised to the power n. And we want to find the sum or n minus 1. There are n terms over here. Now we want to calculate the sum. So the first case we are talking about, it is if r is equal to 1, then all these terms, these are a, so on up to a, and these are n terms. So sum of all these values will be n into a. The sum of all these values will be n into a. The second case is, we are saying when r is not equal to 1. So we are saying the sum of the n terms we will have, that is, we are talking about Sn, that will be equal to a plus ar plus ar square, so on up to plus ar raised to the power n minus 1. Now if we multiply this whole term with r, we will get it is r into Sn. This a is multiplied with r, we will get ar. This is multiplied with r, we will get ar square, so on up to this term when multiplied with, there is a term over here ar raised to the power n minus 2, and it is multiplied with r, we will get ar raised to the power n minus 1, and this last term we will get ar raised to the power n. Now if we compare both these values, this value and this second value, we are adding a to this value and we are subtracting a from this value. So look at this term, over here, a plus ar square, so on up to this. This whole value we have, it is equal to Sn, and we have plus ar raised to the power n minus a. So this implies us that Rsn minus Sn, that is equal to a into r raised to the power n minus 1. So this implies us that Sn is equal to a into r raised to the power n minus 1 over r minus 1. So this is the formula for Sn is equal to a into r raised to the power n minus 1 over r minus 1. So this is the formula for the sum of the n terms of a GP. So this result, it can be written in this way. We are saying when r is equal to 1, it is n into a. We are saying when r is less than 1, we are writing it is 1 minus r and 1 minus r raised to the power n. And when r is greater than 1, we are writing r raised to the power n minus 1 over r minus 1. Why we are writing in this way? So that this r minus 1, it will be positive, this will be positive. When r is less than 1, 1 minus r will be negative, and 1 minus r raised to the power n will be negative. So this whole term we are saying this will be positive. That is why we are dividing it in two parts. Otherwise we have, this is the formula that we have. Next is, if a GP contains n terms with first term a and common ratio r and last term l, then we are saying the sum of this GP, it will be given by, we are saying when r is less than 1, the formula for the sum we have Sn is equal to a into 1 minus r raised to the power n over 1 minus r. This is equal to a in minus ar raised to the power n over 1 minus r. This is equal to a minus lr over 1 minus r. We are having this result. Similarly, when r is greater than 1, we are saying it is lr minus a over r minus 1. So based upon this, we have this question, find the sum of 8 terms of the GP given over here. So the value of a is given to be 3. The value of r we have, it is 6 by 3 is equal to 2, which is greater than 1. The value of n we have, it is 8. We have to find the sum of 8 terms. So the formula for S8 we have, it is a into r raised to the power n minus 1 divided by n minus 1. The answer we get, it is 3 into 256 minus 1, that is equal to 3 into 255, that is equal to 765. So we obtain the final answer as 765. Next is find the sum of the geometric series this to 12 terms. So in this case the value of A is 1, the value of R is 1 by 2 by 1 is equal to 1 by 2, the value of N is 12. So value of S12 will be A into 1 minus 1 by 2 raised to the power 12 divided by 1 by 2, 1 minus 1 by 2. So the answer we will obtain, that is equal to 2 raised to the power 12 minus 1 by 2 raised to the power 11. So if you solve this value, you will get it is 4095 by 2048. This is the answer we obtain in this case. Next is how many terms of the geometric series this will make the sum 5, 4, 6, 1. So suppose we are saying n terms makes this sum. So we have 5, 4, 6, 1, that is equal to value of A is 1 into the common ratio we have, it is 4 by 1 is equal to 4. So we are saying it is 4 raised to the power n minus 1 divided by 4 minus 1. So we are saying that we have 4 raised to the power n minus 4 raised to the power n minus 1, that is equal to 16383. This implies as 4 raised to the power n is equal to 16384. This is equal to 4 raised to the power 7. So comparing these two values, we obtain that n is equal to 7. So it means that sum of 7 terms of this GP, it is 5, 4, 6, 1. Next is find the sum of this series. So first term value of A is given to be 2. Last term is 4374. The value of R we have, it is 6 by 2 is equal to 3. Now the sum, that is equal to LR minus A over R minus 1. So substituting these values over here, we will obtain this is equal to 4374 into 3 minus 2 divided by 3 minus 1. Answer we obtain, it is 13120 divided by 2, that is equal to 6560. So we are saying the sum of the given series is 6560. Next is in a GP, it is being given that T1 is equal to 3, Tn is equal to 96 and Sn is equal to 189. We have to calculate the value of n. So this is the value of A given, this is the value of last term given, and this is the value of sum of n terms given. So we are writing 189, that is equal to L into R. We do not know the value of R, so we are getting it is 96 into R minus 3 over R minus 1. So if we solve this equation, we will obtain that 189 R minus 189, that is equal to 96 R minus 3. On solving this, we will obtain 93 R is equal to 186. This implies us R is equal to 2. Now the last term is given to be 96, L is equal to 96, that is equal to A R raised to the power n minus 1. So we are writing this is equal to 3 into R is 2 raised to the power n minus 1. So on solving this, we will obtain these two terms get cancelled, it is 2 raised to the power n minus 1 is equal to 32. So this implies us 2 raised to the power n minus 1 is equal to 2 raised to the power 5. So n minus 1 is equal to 5, and this gives us n is equal to 6. So what we obtain from this is that the value of n in this case, it is 6. Now next we have to find the sum of the series this, it is 5 plus 55 plus 555 so on up to n terms. So we are saying that we can write this as 5 into 1 into it is plus, not into, it is plus 11 plus 111 plus so on up to n terms. So this is 5 by 9 into 9 plus 99 plus 999 plus so on up to n terms. We have multiplied and divided this equation with 9. Now we can write this is 5 by 9 into 10 minus 1, 100 minus 1, 1000 minus 1, so on up to n terms. So what we get from this is 5 by 9 into 10 plus 100 plus 1000, so on up to n terms, minus 1 plus 1, so on up to n times. We have added this one. So what we obtain from this is, it is 5 by 9 into, this is a GP with common ratio 10, first term is 10, common ratio is 10, minus 1 over 10 minus 1, 1 is added n times, so we are writing it is minus n. So the answer we obtain from this value we get, it is 9. So the answer we obtain, it is 5 by 81 into 10 raised to the power n plus 1 minus 9n minus 10. So this is the required sum that we have. Next is sum the series 0.4, 0.44, 0.444. So again we write it in the form, we write 4 by 9 into, what we are left with is 0.9 plus 0.99 plus 0.999, so on up to n terms. We have taken 4 common, we have multiplied and divided this equation with 9. Now look at this term, we can write it is 1 minus 0.1 plus 1 minus 0.01 plus 1 minus 0.1 minus 0.001, so on up to n terms. So we are getting it is 4 by 9 into 1 plus 1 plus so on up to n terms, minus 0.1 plus 0.01 plus 0.001, so on up to n terms. So what we obtain from this is equal to 4 by 9 into 1 is added n times, so it is n, minus, now this is a GP. The first term of this GP, it is 0.1. The common ratio we have, it is 0.01 by 0.1, that is equal to 10 by 100, that is equal to 0.1. So we are writing it is 0.1 raised to the power. Now this value is less than 1. So we are using the formula in this form. It is 1 minus 0.1 raised to the power n over 1 minus 0.1. So this is equal to 4 by 9 into n minus, this value we have, it is 10, this value 1 by 10, this value we have, it is 1 by 10, and this value we have, it is 9, 0.9, so it is 9 by 10. So on solving this, we will obtain the final answer in the form, it is 4 by 9 into 9n minus 1 plus 1 by 10 raised to the power n divided by 9. So this is equal to 4 by 81 into 9n minus 1 plus 1 by 10 raised to the power n. So this is the required sum in this case. Now in this next question, it is being given that the sum of some terms of a GP is 315 and its first term is 5. A is given to be 5 and the common ratio is given to be 2. Then find the number of its terms and the last term. So the value of Sn is given to be 315 and we are saying it is equal to 5 into 2 raised to the power n minus 1 divided by 2 minus 1. So if we solve this, we will get 63 is equal to 2 raised to the power n minus 1. So this implies us 2 raised to the power n is equal to 64 and this implies us that the value of n we have, it is equal to 6. Now next we have to calculate is the last term. So formula for the last term we have, it is a r n minus 1. So that is equal to 5 into 2 raised to the power 5. The value of n we have, it is 6. So answer we are getting, it is 5 into 32, that is equal to 160. Next is the sum of first 3 terms of a GP is 16 and the sum of the next 3 terms is 128. So it is being given that sum of first 3 terms S3, that is equal to 16, that is equal to a plus ar plus ar square, and 128 is equal to ar cube plus ar raised to the power 4 plus ar raised to the power 5. Now from these two equations we can write, from this first equation we get a into 1 plus r square, that is equal to 16, and from the second equation we get ar cube 1 plus r square, that is equal to 128. So if we substitute this value over here, if we substitute the value in this equation, we will obtain 16 into r cube is equal to 128. So this implies us that r cube is equal to 128 by 16, that is equal to 8. So the value of r we obtain, it is equal to 2. Now if we substitute this value of r in this first equation, we will obtain 16 is equal to a into 1 plus 2 plus 4. So we are getting the value of a is equal to 16 by 7. So we have to find the sum of the n terms of the GP. We have the value of a, we have the value of r. So sum of the n terms of the GP, it is a, it is 16 by 7 into 2 raised to the power n minus 1 divided by 2 minus 1. So it is 16 by 7 into 2 raised to the power n minus 1. This is the sum of n terms of this GP. Next is, in a GP, the sum of first two terms is minus 4. So it is being given that a plus ar is equal to minus 4, and the fifth term is 4 times the third term. So when we are talking about fifth term, it is ar raised to the power 4, it is 4 times the third term ar raised to the power 2. So if we solve this equation, we are saying a is not equal to 0. So r square we obtain, that is equal to, we have r is not equal to 0, a is not equal to 0. So value of r square we obtain, it is 4. This implies us r is equal to plus minus 2. And if we substitute this value of r in this first equation, we will obtain a into 1 plus r is equal to minus 4. So we are having two values. When we substitute r is equal to 2, answer we have a is equal to minus 4 by 3, and when we substitute r is equal to minus 2, the answer we obtain, it is r is equal to plus 4. So we are saying that corresponding to a is equal to 4, we have r is equal to minus 2, and corresponding to a is equal to minus 4 by 3, we have r is equal to 2. So from this first condition, the GP we have, it is 4, minus 8, 16 and so on, and from this second condition, the GP we have, it is minus 4 by 3, minus 8 by 3, minus 16 by 3 and so on. So these are the required GP which satisfy this condition. Next is, in an increasing GP, the sum of the first and last term is 66. So it is being given that it is an increasing GP. So increasing GP means the value of r is greater than 1. Suppose the first term, it is a. So it is being given that a plus ar raised to the power n minus 1 is equal to 66. Now next is, the product of the second and the last but one is 128. So product of the last second means ar, and it is being given last but one means we are talking about second last, it is ar raised to the power n minus 2. Product of these two is 128. Next thing that is given is, the sum of the terms is 126. That is, the value of Sn is given to be 126. We have to find how many terms are there in this GP. So if we look at these equations over here, from this first equation we are writing a into 1 plus r raised to the power n minus 1 is 66. From this second condition we have, it is a square r raised to the power n minus 1 is 128. So if we substitute the value of r raised to the power n from this equation in the first, we obtain it is a into 1 plus 128 by a square, that is equal to 66. So we get a square plus 128 is equal to 66a. So we get a square minus 66a plus 128 is equal to 0. If we factorize this term, we will get it is a minus 2 into a minus 64 is equal to 0. So this gives us two values of a, one value is 2 and second value we are getting it is 64. Now if we substitute this value of a in any one of these two equations, suppose we are substituting the values in this equation number 2, we are getting the value of r raised to the power n minus 1 is equal to 32 or r raised to the power n minus 1 is equal to 1 by 32. Now this thing is not possible because originally it was given that the value of r is greater than 1. So we are saying this case is not possible. So we have r raised to the power n minus 1 is 32 and a is equal to 2. Now next thing that is given to us is that the sum of all these terms is 126. So we are talking about the condition that a is equal to 2, r raised to the power n minus 1 is 32 and value of Sn is 126, that is equal to a into r raised to the power n minus 1 over r minus 1. This value is 126. So in place of a we can write it as 2. So what we obtain is that r raised to the power n minus 1 over r minus 1 is 63. So in place of this r raised to the power n we can write it as r raised to the power n minus 1 into r. In place of this we can write it as 32. So we are getting 32 r minus 1 is equal to 63 r minus 63. So on solving this we will obtain the value of r equal to 2. Now if the value of r is 2 and we substitute this value in this equation, we will obtain 2 raised to the power n minus 1 is 32. So this implies us that the value of n we have it is equal to 6. So there are 6 terms in the given GP. Next is consider two GPs, one is this GP and another is this GP. Now taking the product of their corresponding elements, we obtain this, and which is clearly the GP with first term AR and the common ratio R into R. So we are saying that if we have two GP and we are taking the product, term wise product of these two GP, then the first term of the new GP will be product of the first two terms and common ratio of the new GP will be product of the two common ratios. Now next is find the sum of the products of the corresponding terms of the finite geometrical progressions. These two progressions are given. So it means we have to calculate the value of 2 into 128 plus 4 into 32 plus 8 into 8 plus 16 into 2 plus 32 into 1 by 2. So if we multiply these terms, the answer we obtain, the new GP we have it is 256, 128, 64, 32 and 16. Now the common ratio of this GP it is R is 128 by 256, answer comes out to be 1 by 2. So the sum of terms is equal to A is 256 into 1 minus 1 by 2 raised to the power 5 divided by 1 minus 1 by 2, and the answer we get it is 256 into 1 minus 1 by 2 raised to the power 5 divided by 1 by 2, that is equal to 256 into 2 into, when you solve this value it is 1 minus 1 by 32, that is equal to 31 by 32. So we are writing it is 31 by 32, and on solving this the answer we obtain it is 496. This is the final answer we obtain in this case. Next is find the sum of n terms of the sequence an is equal to this. So if we substitute a is equal to 1, we are getting the value 3 raised to the power 1 plus 5 into 1. Second term is 3 raised to the power 2 plus 5 into 2. Third is 3 raised to the power 3 plus 5 into 3, and so on up to 3 raised to the power n plus 5 into n. If we add all these terms, we will obtain it is 3 raised to the power 1 plus 3 raised to the power 2, so on up to plus 3 raised to the power n. Then it is plus 5 into 1 plus 2, so on up to plus n. So the answer we obtain, these, look at these terms, this is a GP with first term 3 and common ratio is 3, it is minus 1 over 3 minus 1. plus 5 into, these are sum of n terms, it is n by 2 into 1 plus n. So this value, this will become 2. So the answer we obtain, this is equal to 3 by 2 into 3 raised to the power n minus 1 plus 5 by 2n into n plus 1. So this is the sum of these n terms. Next is, if S1, S2, S3 be respectively the sum of n, 2n and 3n terms of a GP, prove this statement. So if we substitute the values over here, we are saying S1 is a into 1 minus r raised to the power n over, it is sum of n terms, 1 minus r, we are talking about S1 into S3 minus S2. This is into a into 1 minus r raised to the power 3n over 1 minus r minus a into 1 minus r raised to the power 2n over 1 minus r. So if we write a over 1 minus r common, we are left with is 1 minus r raised to the power n into 1 minus r raised to the power 3n minus 1 plus r raised to the power 2n. These two 1 gets cancelled. We are left with is a into 1 minus r raised to the power n. From these two terms, if we write r raised to the power 2n common, we are left with is r raised to the power n plus 1 divided by 1 minus r. So this value comes out to be, over here it is minus sign over here. So we are getting the answer as a r raised to the power 2n into 1 minus r raised to the power n square. It is a is common from these two terms. So we have the power of a, we have it is a square over here divided by 1 minus r square. Now if we talk about the term, it is s2 minus s1 square, that is equal to a into 1 minus r raised to the power, we are talking about s2, so it is 2n, sum of 2n terms, it is 2n divided by 1 minus r minus a into 1 minus r raised to the power n over 1 minus r whole square. It is equal to a square over 1 minus r square into 1 minus r raised to the power 2n minus 1 plus r raised to the power 2n whole square. So this 1 and 1 gets cancelled, and the answer we are getting, it is equal to a square by 1 minus r whole square into, from these two terms, we have it is r raised to the power 2n and this value it is r raised to the power n. If we write r raised to the power n common, we are left with is 1 minus r raised to the power n whole square. And look at both these values, we are saying this is equal to, we are saying this is LHS, this is RHS, so RHS is equal to LHS, and this is the result that we have to prove over here. Next is, if S be the sum, P be the product and R be the sum of the reciprocal of n terms in a GP, we have to prove this result. So we are saying that S is the sum, so the value of S we have it is a into 1 minus r raised to the power n over 1 minus r. When we are talking about the product of the GP, product we are writing it is a into ar so on up to into a r raised to the power n minus 1. So answer we obtain it is a raised to the power n, r raised to the power 1 plus 2 so on up to plus n minus 1. So this is equal to a raised to the power n, r raised to the power 1 by 2 into n minus 1 into n. Now the value of r we have, that is the sum of reciprocals we are saying, that is equal to 1 by a plus 1 by ar so on up to plus 1 by a r raised to the power n minus 1. So we are writing 1 by a common, or we are saying 1 by a is the first term over here, and the sum of these terms it is 1 by r raised to the power n minus 1 over 1 by r minus 1. So this is equal to, when you solve this value, this will become 1 minus r over r, this is 1 minus r raised to the power n over r raised to the power n. So the answer we are left over here, it is this r, if we shift over there, we are left with this 1 by a into 1 minus r raised to the power n over 1 minus r into 1 by r raised to the power n minus 1. Now if we calculate the value of s by r raised to the power n, we are calculating the value of s by r raised to the power n. The value of s we have, it is a into 1 minus r raised to the power n over 1 minus r, and the value of r that we have, it is a into 1 minus r over 1 minus r raised to the power n into r raised to the power n minus 1 and whole raised to the power n. So 1 minus r get cancelled over here, just 1 minus r, 1 minus r raised to the power n get cancelled. We are left with this a raised to the power 2n and r raised to the power n minus 1 into n, and we can write this is equal to a raised to the power n r raised to the power n minus 1 into n by 2 and whole square, and this value is equal to p square. This value is equal to p square, and this is what we have to prove, that s by r raised to the power n is equal to p square. Next is, a man has 2 parents, 4 grandparents, 8 great grandparents and so on. Find the number of ancestors during the 10 generations preceding his own. So we are saying the number of parents he has, it is 2, then it is 4, then it is 6, and we have to sum it up to 10 terms. So we are saying the answer we have, it is first term is 2, this is a GP, common ratio we have, it is equal to 2. So sum is 2 into 2 raised to the power 10 minus 1 over 2 minus 1. So that is equal to 2 into 1024 minus 1, that is equal to 2 into 1023, this is equal to 2046. So the number of man's ancestor is 2046. Next is, a man writes a letter to 4 of his friends. He asks each of them to copy the letter and mail to 4 different persons with the instruction that they move the chain similarly. Assuming the chain is not broken and it costs rupees 4 to the mail, there is cost of rupees 4 to mail one letter. Find the amount spent on postage when 6th set of letter is made. Now we are saying the man has posted 4 letters. Now when the next set of letters is being posted, it is being posted by 4 persons to next 4 persons. The next set of letter, it is being posted to next 4 person. We are talking about the 6th set. So number of elements in 6th set, that will be T6 we are talking about. So it is a into r raised to the power 6 minus 1, that is equal to 4 raised to the power 6, that is equal to 4096. Now the cost of posting one letter, it is rupees 4. So to cost of posting all these letters, it will be 4 into 4096, that is equal to, this is rupees over here, 16384 rupees. Next we have is, what will be rupees 10,000 amount in 4 years after it is deposited in a bank which pays an annual interest at the rate of 10% per annum compounded annually. So we are saying that initially the person has added rupees 10,000, and after the end of 1 year the amount will be 10,000 plus the interest will be 10,000 plus 10 by 100 plus 1. So answer we obtain, that is equal to 11,000. Likewise, if we continue, we can continue up to 4 years. And another way to do this is, we can directly use the formula for the compound interest, and it is principal into 1 plus r by 100 raised to the power time period. So we are saying it is 10,000 into 1 plus 10 by 100 raised to the power 4. So we are getting it is 10,000 into 11 by 10 raised to the power 4, and the answer we obtain, it is 14,641. So this is the total amount he will have after 4 years. Next is a manufacturer reckons that the value of machine which cost rupees 1,25,000 will depreciate every year by 20%. Find the value of machine at the end of 5 years. So we are saying now this is the question of depreciation. So the formula for depreciation, it is the initial amount we have into 1 minus r by 100 raised to the power time period. So the value we have over here, it is the initial amount, it is 125,000 into 1 minus rate is 20 by 100 raised to the power, the value we are talking about after 5 years. So on solving this, we get it is, this value is 4 by 5 raised to the power 5. This value we are saying it is 4 by 5 raised to the power 5 into 1,25,000. So the answer we obtain by multiplying these values, it is 40,960 rupees. So this is the final answer we obtain in this case. If you manually want to calculate this value, we are saying initial value of the machine is this, value of the machine after 1 year, the value of the machine after 2 years, the value of the machine after 3 years, and so on. When we calculate this value, after this we are saying this forms a GP. The first term is this, the value of R is 4 by 5, and the sixth term will be given by this formula, and we will obtain this result. Next is the number of bacteria in a certain culture doubles every R. If doubles every R means if initially it is A and the value of double every R means we are saying the value rate that we have, it is 2 multiplied by 2. The first term it is A, then it is 2A, then it is 4A, and so on. Next is if there were 30 bacteria present in the culture originally, it means the value of A is given to be 30. How many bacteria would be present at the end of second, fourth, and nth R? So this A is equal to 30 is at the initial value, then after 1 R, then after 2 R. It means we are interested in the calculating when we are saying after second R, we are interested in the value T3. Then when we are interested in after fourth R, we are interested in the value T5. When we are saying nth R, after nth R, it means we are interested in the value Tn plus 1. So the answers we have for T3, the answer we have, it is A R raised to the power 2, that is 30 into 2 raised to the power 2, that is 120. Next is A R raised to the power 4, the answer we are getting, it is 30 into 2 raised to the power 4 is 480. And last when we are saying nth, it is 30 into 2 raised to the power n. So this is the number of bacteria after nth R. Now next is the inventor of the chessboard suggested a reward of 1 grain of wheat for the first scare, 2 grains for the second, 4 for the third, and so on, and doubling the number of grains for subsequent scares. So what will be the total award of the number of grains that he is to be awarded? So we are saying for the first he will obtain 1, for the second he will obtain 2, for the third he will obtain double of this will be 2 raised to the power 2, double of this will be 2 raised to the power 3, double of this will be 2 raised to the power 4, and we have to add it 64 times. Now look at these terms over here. We are talking about these terms. How many these terms are? These are 63 terms that we have. So we are saying the total number of grains he will be rewarded, it is this. Now sum of these 63 terms, the first term it is 2, then it is 2 raised to the power 63 minus 1 divided by 2 minus 1. We are saying this is equal to, this value will become 1. It is 1 plus 2 raised to the power 64 minus 2. So the answer we are getting, it is 2 raised to the power 64 minus 1. So we are saying the total number of grains to be awarded, it is 2 raised to the power 64 minus 1. Next is the length of 3 unequal edges of a rectangular solid block are in GP. So suppose we are saying the values is A by R and A into R. We are talking about the 3 edges of a rectangular solid block. The volume of the block is 216. So volume means we are talking about A by R into A into AR. This value is given to be 216. So this implies us that a cube is equal to 216. This implies us that the value of a we have it is equal to 6. Next, it is being given that the total surface area is 252 centimeter. So we are saying the value of 2 into length into breadth, it is 6r into 6 plus 6 into 6 by r plus 6r into 6 by r. This value is given to be equal to the sum of these values, it is given to be 252. This value is given to be 252. So if we solve this equation, if we solve these values, the answer we will obtain, it is 72 into r plus 1 by r plus 1, that is equal to 252. So this implies us that 2r square plus r plus 1, it is equal to 7r. So this implies us that 2r square minus 5r plus 2 is equal to 0. So if you factorize this term, the answer you will obtain, it is r minus 2 into 2r minus 1 is equal to 0. So this implies us r is equal to 2 or r is equal to 1 by 2. Now corresponding to these values, we are saying we have the value of a is equal to 6. We have the value of r is 2 or r is 1 by 2. The longest side we will obtain when you substitute these values, we are saying it is 6, and then next value it is 12, and this value we have it is 3. So the three sides we have it is 3, 6 and 12 in both these cases. So the longest side we obtain in both the cases, it is 12. We are saying for the values of r, the longest side we obtain, it is 12.